Alright guys, we're working into 5.3 now. We got the warm-up to do, so give yourself a minute and try it and then check your work. Okay, so here we go. Number one, what's the name of the point? What are the angle bisectors? So looking at the angle bisectors of a triangle intersect. So that's, again, just dealing with some vocab. We did our constructions of this, and if you remember correctly, this should be the incenter. Again, just vocabulary, that's all it is. Okay, number one, just incenter. Now if they said name the point where the perpendicular bisectors intersect, we'd say circumcenter. It's really the only ones we've really gone over at this point. Number 2 and 3 said find the midpoints of the segment with the given endpoints. So again, all we're doing on this, you can call that x1, y1, and x2, y2, and you find your midpoint. It's the average of the x's, so -1 plus 3 over 2, and the average of the y's, which is 6 plus 0 over 2. So that would be -1 plus 3 is 2 over 2. 6 plus 0 is 6 over 2. So your midpoint would be 1, 3. So again, number 2 is just going to be 1, 3 for your midpoint. Number 3, we're going to do the exact same thing. We're going to find the average of the x's and the average of the y's. So -7 plus -3 over 2, and then 2 plus -8 over 2. So we get -10 over 2 and -6 over 2. So divide those, you simplify it out, you get -5. -6 over 2 is -3, and there's your second midpoint for number 3. Again, hopefully doing midpoint and things like this should be pretty simple at this point. If not, well, you're probably struggling in the lessons because we are doing a lot of that, finding midpoint. We're going to keep doing it in this lesson, obviously, because it's our warm-up. Number 4, write an equation of the line containing the following points in point-slope form. So in this one, just so you know, well, I'm going to come up here, and you know your point-slope form. Again, I like to use the h and the k, so I'll go y minus k equals m x minus h. And I'm going to use my point. I'm just going to call, this will be your hk. I'm going to call it 3, 1. You can use either point. I just use 3, 1 because the points are smaller. For the slope, we're just going to do y2 minus y1, so 10 minus 1, over x2 minus x1, so 2 minus 3. So that's 9 over -1, or -9. So your equation is y minus k, so y minus 1, equals m, which is -9, x minus h, so x minus 3. And there's your point-slope form. Alright, so there's your warm-up. Obviously, we're going to be using these things as we go through the lesson today, finding midpoints. This is maybe not necessarily no in-center, but or use in-center in this lesson, but we are going to add some more concurrency points in this lesson, so you want to keep track of which one's which and don't get them confused. But other than that, we will be doing midpoint. We will find the equation of a line, so let's get started. Okay, so our goal for today, we're going to be learning able to apply properties of medians and properties of altitudes of a triangle. These are going to be our 2 new concurrency points, and if you well, I'll tell you later. So this will be a centroid and orthocenter, but we'll get to that in a minute. Okay, so that's what we're going to be doing today. We're going to learn about those 2 new concurrency points. So the first one is going to be the concurrency point for the medians of a triangle. And there are some extra properties that go along with that, just like there were properties that went along with our circumcenter and our incenter. Well, the medians are going to have a property as well. So the median, first off, you need to know what a median is, so I did have one drawn here. A median is going to go from a vertice to a midpoint of a triangle. So that's what a median is. It goes from a vertice to a midpoint. You got to understand there's another segment that goes to the midpoint of a triangle, but that would be a perpendicular bisector. So it does not necessarily go through a vertex. Okay, so those are obviously different. Even though they go through the same point, they don't, the other point isn't the same, right? So that's going to be your median. Every triangle is going to have 3 medians, and they are going to be concurrent. So if you drew the 3 medians, like I have here, and I drew a third one, they are going to touch in the same point. And let's talk about what that point is. That is called the centroid of the triangle. So this is the property that you want to know once you have a centroid. There's also another kind of cool one, although it's not really super relevant unless you have like an application problem where they're kind of giving you this. So you still want to kind of know it. The centroid is the center of gravity. So this would be a fun little trick to try. If we have time in class, we'll try to do it. But if we don't, then you can just try it on your own. But if I took any triangle, doesn't matter which kind I did, and I drew my 3 medians so that they were concurrent, and I put, just kind of say you're putting a little pencil on that. That's a pencil. It's an ugly pencil, okay? I get it. Okay, so, and there's your pencil lead. Anyway, if you put your pencil on that triangle, obviously you'd have to cut the triangle out. It should float on that point. That's kind of neat. It's kind of your way of telling if you got the point right. Just put the triangle on a pointy object and see if it balances. But algebraically, this is what we really need to know. I need a darker color for this. Go black. What we need to know is this. For any segment, I mean, you can see the relationship here where BP is 2/3 BZ, but you can understand that, analyze that. Here's how I kind of break it down. If this length here is x, then this length here is 2x. Okay, so this would, if you look at the entire length, PC is 2/3 of XC. But I like to look at it this way. When you break these two segments up, this is going to be 1/3 of the total length. This will be 2/3 of the total length. But the relationship between the two of them is the smaller length is half of the bigger one. So if this guy was y, that would be 2y. If this one was, I don't know, let's call it p. If that was p, then that would be 2p. So again, those are the relationships we're going to need to be able to see for our centroids. So if we had this figure, we had, you can see we have the 3 medians of the triangle. See how it's going from each segment here is going to go from a vertice to a midpoint. Like J is a vertice to Y, which is a midpoint, and so on. And they are concurrent, obviously, but they're giving you ZW7. So ZW is this piece right here, that is 7. So I know instantly that that is 14 because it's twice as big. If that's x, that's 2x. I know that LX is 8.1, so the whole thing is 8.1. So if that's 8.1, what we're going to do to find XZ, I'm just going to go 1/3 times 8.1 because it's 1/3 of the total length. Remember, if I broke it up into 3 pieces, 2 of them would be LZ, 1 would be XZ. Now in this case, I don't need to do that. I just want to show you that regardless, because I think, remember, that's what we're doing on the next one. Yeah, we're doing that on the next problem anyway. So I'm kind of solving 2 problems at once. So again, I'm going to be solving the next problem while I do this one. Okay. So we're going to just go ahead and find all these links that we have. So for this one, I know I can multiply that by 1/3. That'll give me XZ. But if I want LZ, let me fix that. If I want LZ, I just go 2/3 times the total length. And we just need to go ahead and multiply those 2 pieces together. So if I multiply 1/3 times 8.1, that's going to give me 2.7. Okay, then I'm going to go 2/3 times 8.1, and this one's going to give me 5.4. And again, you can see how 2.7 is half of 5.4 if you double it, and if you add 5.4 and 2.7, you are going to get 8.1. So I have those lengths as well. So I'll just kind of shove those in here. That's going to be 2.7, and that length right there is going to be 5.4. So you'll see KW they're asking for KW. KW is those added up. They gave me the 7. I need to double that to get 14. So that's going to be 21. And if you look at the next problem, they ask you for LZ. So I already found it. Oops, I keep doing that first. LZ. So LZ is this piece right here, the longer of the two smaller pieces, so it's going to be 5.4. That's really, again, both those examples at once. Okay. Again, just learn how to work with those because they're actually not so hard to do if you know how to find the length if you're given the smaller pieces, one of the smaller pieces, or if you're given the entire length as well, like when we were given LX. If you can work with both of those, you should be all right. All right. Next up, here in example 2, we're going to find the average of the x coordinates and the average of the y coordinates of the vertices of triangle PQR. So you have to, if you understand again what this question is asking you when they say find the average of the x coordinates and the y coordinates, remember I say that same type of phrase when we find the midpoints of segments. The midpoint formula I always say find it's the average of the x's, average of the y's. So here in the way when they're asking find the average of the x coordinates and the y coordinates of the vertices, what we're going to be doing is finding the midpoints of those segments. So if I looked, I'm going to call this, I'm going to look at Q, which is 0, 8, and R, which is 6, 4. I'm going to find the midpoint of that one. And they'll call it, let's do these as A, B, C, just because there are going to be 3 of them. So A is going to be 0 plus 6 over 2 and 8 plus 4 over 2. So that's going to be 6 over 2 is 3 and 12 over 2 is 6. I'm going to label that point. So I'm going to go 3, 6. That's point A. And then I'm going to do PR. So P is 3, 0. And R is 6, 4. And here I go again. I'm going to call this point B. So it's going to be 3 plus 6 over 2 and 0 plus 4 over 2. So 9 over 2 is 4.5. 4 over 2 is 2. I'm going to plot that point. So B is going to be at 4.5 comma 2. You can kind of see it right there. And lastly, we have QP. So Q is 0, 8, and P is 3, 0. So I'll call this point C, and that's going to be 0 plus 3 over 2, average of the x's, average of the y's, 8 plus 0 over 2. So that's going to then equal 1.5, 3 halves, and 8 halves is 4. So I have 1.5 comma 4. Okay, so you have those, and make a conjecture about the centroid of a triangle. So again, same thing we have here. We're going to draw these centroid. I'm trying to draw as straight as I can. Not exactly the best, but I'm doing my best, as best I'm able to at least. So here we're going to have our 3 points and just kind of see where that centroid is meeting up. If you do a good job, hopefully you're a little better than me. But let's try to label that point. So I'll call this point, we already have P, I don't know, I guess point X. So point X looks like we are at 3 comma 4. Okay. Now the point of this problem is to find this point but make a conjecture. So we found the centroid, we made a conjecture. Now we need to look at this point and see if is there some sort of pattern that we can look at, and maybe find another way to potentially find the centroid mathematically. And that's what again a conjecture is. If you remember from chapter 2, we're just trying to make an assumption based off of an example. We're trying to make a conclusion. And if I look here, I have my 3 x values. Now let's try to get a relationship here. I have 6, 3, and 0. Now if you took all those values, and we were finding averages, so if I found some averages on this one, I have 6, 3, and 0, so that's 9. if you add them all up. Now I'm not dividing by 2 in this case, but if I divide by 3, I would get 3. So I would say, 9 divided by 3 is 3, which is this point. And if you see if that works here, I got 0 plus 4 plus 8, so that's 12. So I have 12 divided by 3 is 4, and that equals x, which is 3, 4. So I have a conjecture that I can make based off of an example that I did. Said so the conjecture is the centroid of a triangle in the xy plane. I can say Cartesian plane, coordinate plane, whatever. The centroid of a triangle's xy plane is the average of the vertices of the triangle. Again, that doesn't necessarily make this a theorem or anything, it's just a conjecture. We'd have to go a little bit farther to actually prove this so that it works every time, like giving all your points values in terms of variables and working it out that way. But in terms of conjecture, this would be acceptable because we did work out the example. It does work in this scenario, so we can kind of run with that. So again, make sure you understand what it means when I say conjecture. Don't just find the centroid and stop. You have to do that extra step and see what can I kind of get a gleam from this information. Alright, so next up, I said that we have to learn 2 rules today. One is the centroid, and the last one's the orthocenter. Now, the orthocenter actually doesn't have very many properties. It just happens to be a concurrency point. So because there's a concurrency point, we need to label the fact that it is a concurrency point. So the example that you have here, well, first off, the orthocenter is found by finding the altitudes of a triangle. So the altitude of a triangle is a perpendicular segment from a vertex to a line containing the opposite side. Every triangle has 3 altitudes. It can be inside, outside, or on the triangle. So again, if you have an acute triangle, and just so you know, this is going to be called, and I know it's probably on the next slide, but I won't put it here. It's called the orthocenter. Now again, the altitude can be inside, outside, or on the triangle. So if you remember when we did our perpendicular bisectors, we had a very similar rule where the altitudes could be inside, or not the altitudes, the perpendicular bisectors could be concurrent at on the inside, on, or outside the triangle. Well, if we do acute triangles for our altitudes, so if I construct the altitudes, again, what's happening here is I'm going to draw 3 segments that go from a vertice, and it forms a right angle with my opposite side. If it's an acute triangle, this is the orthocenter. I'll call it O for the orthocenter, would be inside my triangle. If I went with a right triangle, this is going to be very similar to a concurrency point for my perpendicular bisectors, because whereas in an acute triangle the orthocenter is inside the triangle, well, here if we have a right triangle, obviously that's a height or an altitude, that's an altitude, and that's an altitude. They all meet at the right angle of the triangle, so that would be point O. So just like a circumcenter, where a right triangle, the circumcenter meets on the triangle, here it meets on the triangle, just at a different point. And then they kind of drew the one, so I'll just put obtuse over here, you can kind of draw that instead. So for an obtuse triangle, notice they all meet out here, and you got to extend these sides when you do the altitude, so it forms a right angle with one of the sides. But so that's all these dotted lines are. They're extending the sides so you can see the altitude. It's like if I just drew a random obtuse triangle and you want to figure out how tall it was, you'd start up here and you'd draw a straight line going down, so that formed a right angle with the base. So that's all they're doing here. So again, you will notice that for circumcenters and orthocenters, the type of triangle you have determines where your concurrency point will lie. So it's important to know the difference on those. But for incenters and centroids, it's always going to be inside the triangle, which is easy to remember if you think about it. So I'll put like a little way of remembering. So the ones that are inside or out are going to be your circumcenter and orthocenter, whereas the ones that are always inside that's going to be your incenter and your centroid. I always say it's easy to remember those last two because incenter, think of the word in, and centroid, think like center, in, and then in the center. So those two are easy to remember. And then orthocenter, like it doesn't sound like inside, like outside, you know, with the O. If you know what circumscribe means, that means to go around something, and you're able to kind of determine, if you know with what the words mean, which ones are inside and which ones can be outside. So again, we're going to have to keep track of those, obviously, when you're going to take the test. All right, so dealing with the medians, I already talked about the phrase orthocenter, so I'm going to skip this slide. And again, the height of a triangle is the length of an altitude. Those are the same thing. That's all it's really saying. Height and altitude are equal to each other. And here we go. This will be our last example. So in this one, we need to show that the altitude of JK passes through the orthocenter. So see what we have. We have a figure here. I got an altitude and an altitude. The question is asking you to show that the altitude passes through the orthocenter, which should be this point. They should all pass through the same point. So I need to find an equation here. I'll try purple. I'm going to start with finding the equation of this line right here. I need to show that if I find the altitude that forms with the base JK, it's going to pass through negative 2, 4, which means I can't use negative 2, 4 to find the equation of that line. Here's what I can do, however. I can use this point here for L. I'm going to actually go ahead and do that now. L is at 2, 2. I'm going to use that point. Okay. Now, in the other end of this, I know that this segment that I'm going to draw, and let's actually call this point O, okay? I know that LO, the segment I'm trying to find, is going to be perpendicular to KJ. So I need to find the slope of KJ. So let's do that. Do rise over run. So 1, 2, 3, 4, 1, 2. So 4 over 2, or 2 over 1. And the perpendicular slope, therefore, is going to be negative 1/2. So I know right now that I have the following point for this altitude, and I have this following slope for my altitude. So the equation for LO, I'll just call it LO, that segment, actually I call it a line, because technically I'm finding the equation of a line, is going to be y equals, not y equals, y minus k, which is 2, equals m x minus h, which is x minus 2. So there's my equation. Now you got to understand what I'm doing now. I want to make sure, and here's what we're trying to show, is that that equation passes through the point negative 2, 4. So this is something we have not done in here before as far as I know. So the question is, does negative 2, 4 pass through y minus 2 equals negative 1/2 x minus 2? If it does, then I've just shown that this altitude passes through the orthocenter, because that's where the orthocenter is located. Now, we know that it should, but we have to prove it. That's the difference between just saying that it passes through it and showing it. I need to see the math here. So remember this is how we're going to do this. You got to understand that this is an x and a y value. It's a point on your line. Therefore, if I take this point and I plug it in, this equation should all equal up. See how these should be equal to each other? Well, that should happen if I plug in a point that's on the line. If I plug in a point that's not on the line, then obviously that equation would not work. Okay, so that's what we're going to check here. I'm going to plug those points into this equation. So y is 4. So 4 minus 2 equals -1/2. X is -2, so -2 minus 2. My goal is to see, are these equal to each other? Well, 4 minus 2 is 2. I'm going to go -1/2. -2 minus 2 is -4. So let's multiply these out. -1/2 times -4/1. So first off, I can see that the negatives will cancel, but on top of that, I also see that those numbers are going to cancel out, and you're going to be left with 2 and 1. So I have -1 times -2. -1 times -2 is +2, and those work. So therefore, LO, line LO, passes through the orthocenter. Booyah. There we go. But this is not just the answer. You can't just say that's your answer. It's about proving it with all that. You have to be able to prove it. This is one of these ones, show your work. Obviously, if it ever says show, you have to show your work. Okay? So, with that, we have our lesson quiz. You'll see in the lesson quiz, 1, 2, and 3 are very similar to the first set of notes we did with the centroid, so go back and look at those. 4 and 5, again, we're going to use that triangle MNP. We have our points here, and find the coordinates of the centroid. Remember, I did that little corollary that might help you find the centroid. That might be a little easier way to do that. And then we have the orthocenter. Again, you can draw the picture, but understand, like I said, that you can use, I would say on these, use the, sorry, gotta get that right. Yeah, so what we need to do is we need to get the, you can use your conjecture that we did earlier for the, for the medians, but for the centroid. And also point slope form. Use that for your orthocenter. Yes, it takes a little bit of algebra. That's expected of you, so you should be able to do that. Don't just try to not eyeball it. Don't just try to just throw something together. Use your notes. Your notes are there for a reason. So number 4 should be super easy. Number 5, it takes a little bit of work, but I just did it for one of your lines. You just need to do that for your other 2 lines. That's all you need to do. The only thing with number 5, we actually don't even, the rule for the orthocenter, so you don't even need to do that last step that we did. I mean, just find this dang line. Once you find it, you should hope. You can check to see if they all cross through the same point, if you can graph it and find that point. Otherwise, just get those 3 equations. That's really all I'm asking you to do. So go ahead and do that. Don't make excuses why you can't. Just get it done, all right? So do that, and don't forget your reflections, and I'll see you guys in class.